Stay in tight formation.
This video is brought to you by Creative Shrimp. Stick around to find out how you can save 25% on all of their Blender courses. Lens flares, oh wait, hold on, this one's just for me? One moment. Yes, lens flares. During my career as a professional compositor, I've used lens flares on everything from small ads to Hollywood blockbusters, and they do a lot to bring a scene together, adding that extra bit of polish and realism. They can, however, be a bit tricky to create if you're not sure what you're doing. The options we have in Blender by default are generally either some streaks, glow, or these little things Blender calls ghosts. Overall, this isn't much to work with. You can get some decent results with it, but they aren't terribly exciting. They are also not terribly realistic, as lens flares are usually comprised of lots of different elements which move, distort, and scale differently, often with color variation, blurring, and other effects. That's very hard to achieve with just a couple of basic features. This leads most people who want more accurate, cinematic, or customizable lens flares to go to external programs, such as optical flares by Video Copilot, or Blender add-ons such as Flared or Flare Wizard. All of these tools work well and have their place. But tools like optical flares aren't built for Blender, so they require extra software, and they aren't cheap, nor is the software they require. Meanwhile, the add-ons that are available for Blender are generally designed to be used in a 3D environment. They don't work well if you're trying to work with real footage. Not to worry, because today I'm here to give you a completely free system for lens flare production and show you how to use it, along with an example scene that you can use to test it out. This system I've built has a few drawbacks, mainly that it's a bit slow due to the speed of Blender's compositor, but it will let you put lens flares on anything at all. I built this system to function just like the systems I use as a compositor for major films and streaming shows, and now you can use it too. You can use it on 3D renders, real footage, still images, or videos, and the only thing you need is Blender. No add-ons required. There are some presets ready to go, but you can go ahead and make your own from scratch, or even customize the presets to your heart's content. If you'd like to follow along, you can download the lens flare system file and the example scene from the links in the description. Or you could head over to the CG Boost website's resources page and download the files along with a bunch of other interesting things you might find useful. Before we begin, for those who don't know, a lens flare is essentially an imperfection that appears in footage or images when a particularly bright light source, such as the sun, bounces around the inside of the lens of the camera. This leads to the light from the source spreading out across the image, often in fairly intricate and interesting ways. When it comes to making 3D renders look realistic, adding imperfections like this can go a long way to making the images look more like they were captured with a real camera, which is always a good thing for improving the quality of the result. Aside from realism, they can also add a lot of character to a scene. For example, by making sunlight seem more harsh in a desert scene, lights in a sci-fi scene more futuristic, glow from within a mystical object seem more magical, and so on. Plus, they are cool. This is an undisputed fact. So let's look into this new system I've built and work out how to add some flares to your work. If we open up the .blend file provided in the flare system files, you should find yourself looking at the compositing workspace. If you're not in the compositing workspace, you can get there by clicking the compositing tab up the top, or if that's not available, by pressing this little plus button and under VFX, select compositing. Right, so in the node graph, you should see all of this stuff. I've grouped the various parts of the system so that it's nice and clear which bits are which. On the left, we have the various flare element shapes. There are quite a range of shapes in here, including glows, these strange hoops, some basic geometric shapes like circles, octagons, and pentagons, along with a variety of different streak and glint types. In short, hopefully all of the shapes required to make just about any flare you want, but you're more than welcome to make your own shapes and use those instead. In the middle here, we have the different flare element types. This is the core of how the flare system works, and to demonstrate what I'm talking about, I'll do a very quick demo of what the elements do. If you aren't interested in knowing how to build flares from the ground up, you can skip to this point in the video, where I'll just show the preset flares and how to use them. Let's start with a static element. This basically means a flare element that will follow the movement of the light source around, but nothing else. So I'll copy this static element group with Ctrl-C and paste it down here with Ctrl-V. You could just duplicate it, but then the frame follows you around, which is a bit annoying. Release me at once! Anyway, to make this element do something, first we need to pick the shape the element will have. So we come over here and pick one. I'll just go with this streak shape, so I'll copy that and paste it over here next to the element group, and then plug the shape's image output into the element shape input of the static element group. Now if we look at the output of the group, we now have that streak as the result. Once we've chosen the shape we want, we'll need to adjust the various settings on the group. First and most important is the scene resolution's X and Y values. A lot of the calculations that are taking place in the groups are based on this, so if you get it wrong, it will probably just not work correctly at all. For the sake of demonstration, I'll just use 1080p resolution, so that's 1920 in the X value and 1080 in the Y, but you can use whatever resolution you prefer. Try to match it with the scene output settings to make sure it renders properly. Now the most important part we need to worry about is exactly where the flare will be, determined here by the source X and Y variables. I'll go through how we can get these values for an animated scene automatically using tracking data later, but if it's just a still frame you're working on, it might just be easier to type the values in. A good trick for working out what the values should be is to come up to the image editor here and hold down the right mouse button. Down here on the left you can see the X and Y values of where the cursor is on the image. Very helpful. I'll want the flare to be over here somewhere for the demonstration, so I'll set my X to 550 and my Y to 750. With that, our element should jump to the desired location. If we were to have an animated position for our flare source, by animating these values or by feeding it tracking data, the element would follow the animated coordinates around. You'll see that in action later in the video. We also have an aspect ratio option here for anyone playing around with anamorphic lenses. Now this next part is where we can get a bit creative with the actual look of the flare. X offset moves the element left and right relative to the source, and Y offset moves it up and down. Mirror intensity determines how the element follows the source position. When it's on 1, it will match the position perfectly. On -1, it will mirror the position against the center of the image, basically doing the opposite of whatever the source position is doing. And that value can go as high or low as you like, allowing for quite a bit of flexibility. Element angle rotates the element, and as you might expect, element scale makes the element bigger or smaller. Squash X and Y compress the element in a particular direction, but crucially, it performs this action before the rotation. So if you rotate the element 90 degrees so that it's on the side, the squash direction will rotate with it. If you want to have it squash vertically or horizontally after the rotation happens, you can use the aspect ratio variable. Blur is fairly self-explanatory, blurring the element out. Distortion applies a lens distortion effect to the element, allowing it to bend as it approaches the edge of the image, and aberration applies a chromatic aberration effect, so that the colors separate as the element gets closer to the edges. Finally, the mask allows you to plug a black and white image or a mask into the element to make it dim as the source is covered up. That can be very helpful if you have something like sun through the leaves of a tree, and you want the flare to automatically turn on and off as the leaves block the light source. The various settings I've described are mostly consistent over all of the different element types, but the different elements do slightly different things. Firstly, as I mentioned before, the static element just animates its position to match the movement of the source. The rolling element does the exact same thing, except it will automatically rotate around the center of the image, giving a bit of easy animation to your flare. The hoop element is mostly the same as the rolling element, but it will automatically scale up and down based on how far away the source is from the center of the image. There is also no ability to change the offsets, mirror intensity, or element rotation for a hoop element. And finally, the multi-iris element is the same as a rolling element, except that it will place up to 10 of the same shape randomly along the mirror intensity line. It will give the elements it creates a random scale, and you can also give those elements some random color variation, which can add a nice bit of visual interest to your flare. The multi-iris element is by far the slowest of these to process, so I would suggest adding them later or disabling them when you're adjusting other elements in your flare. To combine multiple elements together, just connect them up through the flare inputs and outputs, and you'll have a custom flare in no time. Hopefully one that looks a bit better than this one. And that's about it. If you want to have a better idea of how to use these elements together, you can have a look inside the preset groups and see how I built those. Now let's take a look at the preset flares over here on the right. These are some very good examples of the kind of things you can make using this system. To see what they look like, you can just connect a viewer node to the flare output of the node group. A quick and easy shortcut for this is holding Ctrl and Shift and left clicking the node you want to view. If you don't have a viewer node in the graph, it will even make one for you. Very handy. They do take a little while to process due to the slow speed of Blender's compositor, but once it's done you can see the result. In the system files, I also provided a preview image for each of the flares, so you can see at a glance what each preset looks like without having to wait for them to process. You can see here on the preset groups we have the scene resolution, flare position, and mask inputs, along with some basic controls for easily adjusting the overall look of the flare. Hue shift changes the overall color of the flare without changing the intensity at all. Tint allows you to push the overall color of a flare towards a particular color in a more user-friendly way than hue shift, but it will dim the overall result a bit, so just watch out for that. Saturation allows you to reduce or increase the intensity of the colors, and intensity allows us to easily make the flare brighter or darker, and can be used to easily animate when the flare is on or off. And all the way down the bottom we have an overall scale variable which lets us scale the whole flare up or down as needed. If you need to adjust a particular element of the flare, you can go into the group and change the various elements individually. For example, you might want to turn off some of the streaks and make the glow brighter. Who knows, but you have the control there if you need it. If we hop over to the 3D scene part of the flare system file, you can see that I've also set up some red, green and blue emissive spheres that you can append into a 3D scene to provide an easy tracking marker should you need it. If you're using real footage for your shot, these probably won't be helpful, and you'll likely find it a lot easier to simply track a part of the footage. I'll go through how to track something a bit later. Have you ever felt like your lighting isn't quite getting that cinematic feel you're after? Perhaps you want to learn how to 3D scan real objects for unparalleled realism, or create spectacular nebulae for your space scene. If this sounds like something you might find interesting, then I can highly recommend Creative Shrimp's Blender courses. They have a whole range of courses covering everything from cinematic lighting and procedural texturing to stylized art and 3D scanning. I took their hard surface modeling and space VFX element courses when I was starting out in Blender, and I can personally attest to the high quality of their products. Alongside their courses, the experts over at Creative Shrimp also have their dust particles asset that can even be used to create a star field to go with your fabulous new lens flares in a space scene. There is also a free version, so there's no reason not to go check it out. The experts in question, Gleb Alexandrov and Adi Burrows, are longtime friends of CG Boost, and they have kindly offered 25% off on all of their courses for the first 100 people using the coupon code SHRIMPBOOST. That's a funny name. Follow the link in the description to go over and have a look at what Creative Shrimp has to offer and kickstart some amazing art right now. Or maybe when the video's over. Yes, finish this video first, then go have a look. In amongst the flare system files, you should also have downloaded an example scene. Let's open that up and have a look at what we have. It's a fairly simple scene depicting these spaceships flying towards a planet. All of the planets are renders I placed into the scene as image planes, so they're nice and quick to render, along with being quite easy to move around. In the background, we have this little sphere, which is going to be our light source. It should all be set up to render for you, but in case you don't feel like rendering out this whole 200 frame shot, I've provided my own renders for this shot in the downloads as well, so feel free to just use those. To make sure we have an easy point to track, I rendered out an emissive pass for the scene along with the regular render. Making an emission pass is a very easy thing to do. Just come over to the Render Layers tab of the Properties panel and activate Emission. You won't be required to do this in the example scene, because I've already set it up in this linked copy of the scene, which will render out automatically with the regular render. So assuming it all rendered out okay, or you're using my renders, let's have a look at the result. In a fresh Blender file, import the beauty and emission image sequences into the compositor's node graph. My preferred way of doing that is by accessing the Add menu with Shift A, then selecting Input, then Image Sequence. Navigate to wherever you saved the image sequence you want, select any of the frames, and then select Import Image Sequence. It will then create the image input node, set it to Image Sequence, and even set the correct number of frames. Too easy. We have the spaceships flying around in the beauty render, and just the sun and the thrusters visible in the emission. Perfect. We can use this emission to add some nice glow to the thrusters and the sun, but let's not worry about that for the moment. All we care about right now is how to add a flare into the scene. The reason why exporting an emission pass is so useful in this case is because it allows us to easily isolate the sun in the scene, making for an easier object to track. This would also be true of those tracking dots I provided in the flaresystem.blend file, as they have emissive materials as well. So if you render an emission pass on a scene using those, you should just have those tracking dots by themselves on an otherwise black render, assuming you don't have any other emissive materials in the scene. But you can always turn those off for that render, like I did with the background in this scene. Okay, so let's track the sun position. Switch over to the motion tracking workspace by selecting it in the tab up the top, or by clicking this little plus button here and selecting VFX, then motion tracking. We're going to be tracking the emission render, so to bring that in for tracking, click the Open button here, navigate to wherever you saved the emission render, select any of the images from the sequence, and select Open Clip. It should bring in all of the frames of the sequence, but it won't automatically set the frame range, so let's change the end frame to 200 to match the number of frames in the image sequence. At this point, if you scrub through the frames in the timeline, you can see that it's not too bad, but it's still not smooth. To fix this, click the Prefetch button over here. That will pre-process all of the frames in the sequence, indicated by the lighter blue on this line here. Now it should be much smoother, but for ultimate smoothness, just hit the play button down here and wait for it to go through the entire shot a couple of times. That will let it properly process every frame, and now we can move backwards and forwards without any skips or freezes. Now the thing we're wanting to track is the sun position, which we can see enters the shot around frame 94. It starts here and then stays in view right up until the end of the shot. There is also no motion blur at the end of the shot, so to make sure we're getting a nice clean track, let's create our track at the end and track backwards from there. So to create a tracking marker, click the Add button in the marker section and then click on the sun. It will have added this little box shape. This is what a tracking marker looks like. Click and drag on the center of the marker to move it around, and use this little handle off to the side to scale and rotate it. To get the best tracking results, put the marker in the center of whatever you're trying to track, and scale it up so that it's a bit bigger than the target shape. You can make it the same size, but if there's any motion blur or the shape gets any bigger, it will quickly overlap the marker edges, and then the marker won't know exactly where to go. Once the marker is in place, come over to the side panel, and in the Track tab, you should see this little window displaying what the marker is covering. You can also click and drag in this preview to move the marker around with a great deal of accuracy. There are a lot of controls and options for tracking, but we won't worry about them for this demonstration, as they would likely be a series of videos by themselves. For now, we have all we need, so let's track the sun backwards by pressing this little button here, which tracks the target back until it runs out of frames or it can't find the shape anymore. It should very quickly track the sun position from frame 200 back to around frame 97. If we move to frame 96 now with the left arrow button, the little preview window has blanked out and the sun position hasn't been tracked. This is because, as I mentioned earlier, the sun's motion blur has become too big for the marker, so it doesn't know what to do with it. It thinks the shape has disappeared, so it stopped the track and deactivated the marker, which we can see by looking at this little eye symbol next to the marker's name on the side panel. We, as wise human beings though, know that the shape is still there, so we can keep going with it. So reactivate the marker by clicking on the little eye symbol, and just manually move the marker so that it's in the middle of the sun again. You may find it easier to position if you scale it up a bit. Scale and rotation don't matter for individual markers, as the only thing they output is their position. Once you have the marker in place, go back another frame and do it again, and then do it again, and then do it again, until you lose sight of the sun. It doesn't have to be super accurate because the flare will cover up any tiny deviations from the exact positions. Incidentally, you don't have to be using a super clean tracking target like this. You can track anything at all, in both real footage or 3D renders. You could track a light source, colourful dot on the wall, someone's eye, or even your favourite rock. You will get better results the more distinct the tracking target is though, so try to make whatever it is stand out. For example, your favourite rock might not work if it's surrounded by other, less exciting rocks that are all the same colour. This is why we're using an emission render for the track. The sun is very, very different from the surrounding blackness of the background, so it's extremely easy to track. Once the sun leaves the edge of the frame, we're going to make an educated guess as to where it's gone and keep going for a few frames, to around about frame 85. This is to allow us to have the flare appear a little bit before the sun is visible, so it doesn't just suddenly switch on. To finish things off, I'll just rename the tracking marker to Sun Position. This will help me identify it in case I decide to add a bunch of other tracks to the scene. Now comes the fun part where we actually get to add the flare to the scene. First, let's make sure we're in the compositing workspace, as this is where we'll do everything from this point forward. Now go to the File menu, select Append, and navigate to wherever you saved the flare systems.blend file. Within that .blend file, go into the node tree folder, and you will be presented with every node group available in the file. While we do have every single node group used by the flare system sitting there, the only ones we're concerned about are the ones with the word preset in the name. So I'll just go up here into the search bar and type in preset to isolate those. There should be 8 options ready for you, and if you need a reminder of how they look, remember that we have those preview images. For this scene, I'll use the first preset called Conspiracy. So I'll select that and click Append. It will look like nothing happened, but if we press Shift A to bring up the Add menu, then hover over the Group submenu, we have imported all of these groups. The reason it dragged all of these into our file rather than just the preset group is because the preset group contains copies of all these other groups, so it brought in everything that was within that preset. So select the preset group and put it somewhere here in the node graph. To put it over the scene, we'll use a Mix node. So get one of those from the Add menu under Color, Mix, and there's our mix color. Connect the top input to our scene render and the bottom to the lens flare. Change the mix type to Add so that it mixes our flare with the scene properly. Wait a few seconds. And hooray! We have a flare in the scene. It isn't in the right spot though, so let's fix that. First, let's make sure the preset scene resolution matches that of the rest of the scene. In this case, the scene and the renders are in 4K resolution, so I'll change the values of the group to match that. I find an easy way is to just copy and paste the values over from the scene resolution. Then we want to use our tracking data to put it on top of the sun. So go back to the Add menu, and under Tracking, create a Track Position node. This is the node that brings in the tracking data we made before. From the little drop-down menu on the left of the node, select the Emission Image Sequence. 2 little text boxes should then appear on the node. Click on the top box and select Camera. Tracking data, for some reason, is stored inside cameras in Blender, so that's the object that we'll need to reference. Now for the second text box, select our sun position track. Then connect the X and Y outputs to the source X and Y values on the flare preset node. And just like that, the flare will snap to the sun's position. To make sure our flare turns off at the right time, on frame 93 where the sun starts disappearing off the edge of the screen, I'll set a keyframe on the intensity value. Then I'll go back a few frames to frame 85 and set the value to 0, keyframing it again. Now the flare will turn on at the right time and animate to match the sun's movement. From here you can play around with the look of the flare, adjusting the scale, color, and even go into the node group and adjust individual elements if you like. I would suggest rendering the flare out separately and combining it with the scene as a rendered element, rather than processing the flare on every single frame, every single time. This would allow you to make adjustments elsewhere in the scene without it being slowed down by the flare's processing time, but that's more of a preference thing. Well, that's about all there is. Feel free to use the system for anything you like. There's no copyright or control issues to be had, so go nuts and add flares to everything. And don't forget to follow the link in the description and use the coupon code SHRIMPBOOST for 25% off any of Creative Shrimp's courses. If you found the video useful, please do consider liking and subscribing, as it really does help us out a lot. And I would personally love to see the results you're able to get, either in the comments or in the CG Boost community. Now go forth and make some visual magic.